So in the last video, we talked about what is the discrete random variable, continuous random variable, and what is the normal distribution. Okay, so normal distribution is a continuous probability distribution that is symmetric, bell-shaped. So symmetric about the middle, right? That means the mean, median, and mode. Median and mode are all equal in the middle. Okay, and then this is symmetric about that mean, median, or mode that lies in the middle. And then if you cut it in the middle and then just fold it, these two parts that match. Okay, that is the, and then it is continuous random variable. There is no hole or break. Okay, so this is the graph of the normal distribution. Okay, now, so what we say is, see, if you expand this in either direction, if you go to the left or the right direction, okay, it never touches x-axis too. Okay, this is x-axis is basically the asymptote, horizontal asymptote to this graph. Okay, now, so the total area under this is basically the 100%, because the total area is always, total is always 100%, right? So the total area under this is 100%. So you can think that 100% is basically the 1, right? So 100% and 1 are the same thing. So the total area under this curve is 100%. That is, we assume that is 1. All right. Now, so since the mean is in this middle, and median, mode, all of them are in the middle. Now we want to know what percentage of within what percentage of the data, or what percentage of the area are within the 1 standard deviation from the mean, within 2 standard deviation from the mean, within 3 standard deviation from the mean, and so on. Okay, so let us see that. Remember that the area under the normal curve that lies within 1 standard deviation of the mean is approximately 68%, meaning about 68% of the area, because the total area is 100%, total area under this curve is 100%, right? About 68% of the area lies within the 1 standard deviation from the mean. Okay, do you remember that the Chebyshev's theorem, Chebyshev's inequality? It says that we had the formula like the percentage equals to 1 minus 1 over k square, right? Where k is the number of standard deviation from the mean. But in case of the normal distribution, more area basically lie within the this is the percentage, within the 1 standard deviation, 2 standard deviation, and 3 standard deviation from the mean, meaning that about 68% of the area lies within 1 standard deviation from the mean. How do you find out 1 standard deviation? Is mu plus sigma and mu minus sigma. This is mu plus sigma is 1 standard deviation bigger than mu, and mu minus sigma is 1 standard deviation smaller than mu. So this is within 1 standard deviation. Okay, so within 1 standard deviation, about 68% of the data, or 68% of the area, lies within 1 standard deviation. The total area is 100%, so 68% of the area lies within 1 standard deviation from the mean. Similarly, about 95% of the area lies within the 2 standard deviation from the mean, and about 99.7%, okay, of the area lies within the 3 standard deviation from the mean. Okay, so it is mu plus sigma, mu minus sigma, and mu plus 2 sigma, and mu minus 2 sigma, and mu plus 3 sigma, mu minus 3 sigma, meaning within the 3 standard deviation from the mean, about almost 100% of the data, or 100% of the area lies within the 3 standard deviation from the mean. This is the fact about the normal distribution. Okay, now standard normal distribution. So since each normally distributed variable has its own mean and standard deviation, the shape and location of these curves will vary. In practical application, one would have to have a table of areas under the curve for each variable. To simplify this, statisticians use a standard normal distribution. It is not very necessary to have a standard normal distribution because you have a calculator. Okay, before the graphing calculator, or before the calculator that gives you the probability between any two values, we used to rely in the table only, and the table needs the standard normal distribution, meaning the g values, all the x values should be changed into the g value. You will see what is the x value and the g value. Okay, in that case we need to change all the data into the standard normal distribution. That's what we need to do. But these days you have a calculator, you have a graphing calculator, you have a calculator that has the probability distribution, so you don't have to change into the g value. Okay, but you can still change into the g value. I will show you both ways, okay, how to do using the g value. But let's say what is the g value, or what is the standard normal distribution. So by the way, let me write down, if x is a random variable that is normally distributed, normally distributed, then we write like this: x is approximately normally distributed with mean is mu and standard deviation is sigma. This is how we write. This means x is normally distributed with mean mu and standard deviation sigma. Okay, that is the normal distribution, normally distributed random variable. X is a random variable which is normally distributed with mean mu and sigma as a standard deviation. That means the graph will be a bell-shaped graph with mean is at mu, and then within one standard deviation there is 68% of the area. The total area is 100%. Within one standard deviation 68% of the area lies. Within two standard deviation 95% area lies within two standard deviation, and within three standard deviation 99.7% of the area lies. Okay, that's what the normal distribution means. Now, what is the standard normal distribution? The standard normal distribution is the normal distribution if the mean is 0 and the standard deviation is 1. If a normal distribution has mean 0 and standard deviation 1, that is called the standard normal distribution. For the normal distribution we denote by x. For the standard normal distribution we denote by g. Okay, so what we write is g is normally distributed with mean 0 and standard deviation 1. Okay, if you go to the back of the book, there are tables. Okay, the table E give you the area under the standard normal curve, that is area under the g curve. But since we will be using calculator, you don't have to have g value. You can find the area directly using the x. But before the calculator, we used to use table E, so we needed to find the g value for each problem. Okay, we will see. I'll show you both methods. Okay, so what it says is, to find the area under a normal curve for any random variable with any mean and any non-zero standard deviation, we first change all the random variable into standard normal variable. That is before, but now you don't have to. Okay, I'll show you both methods. As before, we have the g value in the chapter, I think it was chapter 3, we found the g value. Okay, the g value is the number of standard deviation that a particular x value is away from the mean. The formula for finding the g value is the value minus mu over standard deviation, that is x minus mu over standard deviation. This is the formula to find out the standard normal variable. Okay, so let us see this example number 1. For a distribution with mean mu is 25 and sigma is 2, find the g value for 24. So x equals to 24 is given. You need to find out the g value for this x. Okay, what is the formula? G is equals to x minus mu over sigma. What is mu? Mu is 25, sigma is 2, right? So what you do is x is 24 minus 25 over 2. That is basically how much? Negative 1/2. That is negative 0.5. Okay, what does g says? G is how many standard deviation above or below that x value is. So we found g equals to 0.5, negative 0.5. That means this x value is negative or 0.5 standard deviation below, because it is negative. Okay, so 1/2 standard deviation below from mean, and that is true, right? Because mean is 25, standard deviation is 2. What is 1/2 of the standard deviation is 1. 24 is 1 less than 25, right? That is 1/2 standard deviation less than mean. That's what the g gives you. G gives you how many standard deviation above or below the particular x value is. So here we found g equals to negative 0.5, meaning x is 0.5 standard deviation below, because it is negative, so we say below the mean. Now let's find out for 28. So x equals to 28, right? What is g? G is 28 minus x minus mu over sigma. That is 3/2, right? That is 1.5. What does that mean? That means this particular x value is 1.5 standard deviation above. What is 1.5 standard deviation? 1.5 standard deviation is 2 times 1.5 is 3, right? This is 3 above the mean. 28 is 3 above the mean. That's what it means. Okay. All right. So that's this thing we discussed that already. With standard score, standard normal curve, the equation x minus mu over sigma, if you do that, you will get this value. Okay. So y, the curve will be 1 over sigma root under 2 pi e to the negative g square over 2. Meaning that this standard normal curve change any normal distribution with any mean and standard deviation with a normal distribution with 0 mean and standard deviation 1. Okay, again, this is not necessary for now. Okay, there are some questions that ask you to find out g value. All right, but you can find out without finding the g value. You can find out the area without finding the g value. Okay, let us discuss how do we find out area under a normal curve or g value. Okay, or standard normal. It should be standard normal curve. Standard normal curve. Okay, how do we find out the area under a standard normal curve? So to find out the area under standard normal distribution or left to g, we use table E. If you go to the book and then if you see the table E, that will tell you what is the area under a g value. But again, we will be using calculator, so you don't have to worry about the table E. We will use calculator for that. Okay, how do you use calculator? Is you in the calculator you do second, you press second and then verse and then go to normal CDF. Okay, second, verse and normal CDF. So our goal here is we want to find area under a normal curve. Okay, to find out the area under a normal curve, sometimes the question asks what is the area left of g, left of this g or that g, this shaded area. What is that area? What is the total area? Because we know that the total area under the normal curve is 100% or 1, right? But if you want to find out what is the area left of this value or what is the area left of this value, then we use calculator or the table to do that. Okay, so the area is, to find out the left area, you use negative 1000 and you use the upper bound and then g, okay, and then mu equals to 0 and sigma equals to 1. You need to upper bound of g. We'll see example and then press enter. Okay, how do we do that? Let us see this. So what it says is in example 2, it says find the area left of g equals to 1.2. Again, what we said is under the standard normal curve, the random variable with mean is 0 and standard deviation 1 is called the standard normal curve. We call this is the g distribution. Okay, it keeps going in the either side. Now we are trying to find out area under this g distribution. Okay, right of 0 there are positive values 1, 2, 3 like that. Left of 0 there are negative values, negative 1, right, negative 2, negative 3 like that. Okay, this is symmetric and mean is 0. That's why we call standard normal distribution. If the mean is 0 and standard deviation is 1, it is called standard normal. If the mean is different from 0 or standard deviation is different from 1, that is just a normal distribution, not a standard normal distribution. Okay, for the normal distribution or the standard normal distribution, to find out the area, then we use a calculator to do that. Okay, for example, let us look this. What does this question says? It says find the area left of g equals to 1.2. What is g equals to 1.2 is? This is positive 1.2. 1 is here, right? 1.2 may be somewhere here. What the question says is what will be the total area left of that? What is the total area left of that? We know that the overall area under this curve is 100%, right? So this green shaded area must be less than 100%, right? I would say it must be greater than 50% because area left of 0 is 50%, area right of 0 is 50% because it is symmetrical. Since you are trying to find out area left of 1.2, because this point is 1.2, this area must be bigger than 50%, right? But smaller than 100%. All right. Now I want to use this in the calculator. Okay. I'm showing TI-84 calculator, but I will show you how to do that in TI-83 calculator as well. Okay. So this is the TI-84 calculator. Okay. Now, so what we do is, as I mentioned, what did we do to find out the calculator? Is go to the second and then vars. Press second and then vars. And then there is a normal CDF, normal PDF like that. In number 2, it is normal CDF. You need to go to normal CDF. Let's go to normal CDF and then hit enter. In the enter, after you hit enter, let us go to this figure here. What is the left bound? Because to find out the area, the calculator asks you to find out, enter the left bound and the right bound for this shaded region. Because you are trying to find out the area of this shaded region, right? What is the left bound? It keeps going on the left, and then you are finding all the area left of 1.2, right? So the left bound, it is the default value, it is -1, it is 10 to the 99. But if you don't want, you can write -1000 there. Because it is, you go to the extreme left, because this says area left of 1.2, meaning you go all the way somewhere here, right? That means you can write -1000 or -100. Since your calculator has 10 to the -10 to the 99, it is very small number. That's fine to use that value. Okay. Upper bound. What is the upper bound? Upper bound is the right bound here, right? So upper bound is 1.2. Type 1.2 there. 1.2. Okay. And what is the mean? Mean is 0, sigma is 1. This is the default value. Why? Because we are saying G distribution. G value. That means it is the normal distribution with mean 0 and sigma 1. That is for the G distribution or the G value. But if the mean is different from 0 and standard deviation is different from 1, then you will have to plug in that there. Okay, that will be the X distribution. That will be just the normal distribution. But this is the standard normal distribution because mean is 0 and sigma is 1. And then what we do? Hit enter again. So this is what you get. Okay. Now, if you are using TI-83 calculator, you need to find out normal CDF the same way we did, and then you need to enter that -10 to the 99, or you can do -100. That's fine here. And then do left bound, right bound, and then 0 and then 1. This is for the standard normal. Okay, left bound, right bound, and then 0 and then 1. Since this question ask the area left of 1.2, the left bound is you should pick very small number like -10 to the 10 or -10 to the 99. The calculator picks -10 to the 99. 1 e to the 99 means -10 to the 99. Okay, but you can enter -10 to the 10. That is perfectly fine. Okay, and the right bound will be 1.2. This is 1.2 because you are asked to find out the area left of 1.2, and 0 and 1 are the mean and standard deviation. Because this is the standard normal or the G curve, so it says G means the mean is 0, standard deviation is 1, and let's hit enter. Okay, if you enter, you'll get 88.8849. That's what you got. So you got the area left of this is 0.8849. So 0.8849. This is same as 88.49%. Okay. The total area left of 1.2 is 88.49%. You know that the overall area is 100%. The area left of 1.2 is 88.49%. Again, if you are using the TI-83 calculator, you need to go to second and then vars, right? And then you do normal CDF. After you pick normal CDF, your calculator starts with the parenthesis, and then you do left bound, right bound, and then 0 and then 1, right? Because it is the G distribution. So in this case, what will be the normal CDF? It will be normal CDF. Left bound is -10 to the 10, right? Right bound is 1.2, and then 0 and then 1 is for the mean and standard deviation. If you do that, you will get that number. This is for TI-83. For TI-84, as you do second, vars, and normal CDF, and then the calculator automatically picks those values, right? So the calculator automatically picks those values. What were those values? These are the values there. All right. So this is for the area left. Okay. So one of the thing that is very important is the calculator always find the left area. Okay, the calculator always find the left area only. If you enter the number, it will finds the left area. TI-84, but the very latest version of TI-84 ask you, do you want to find left area, right area, or the middle area, and then you will pick that. Okay, but in TI-83 and old TI-84 version of calculator, it always find out the left area. Let us do another example. Example number 3. Find the area left of G equals to negative 0.23. Let us make a curve. So this is the standard normal curve, G curve. Okay, there is 0 in the middle because it is the G. G distribution means mean is 0 and standard deviation is 1. Okay, now so since it says left of negative 0.23, so where is it? Is it left of the 0 or right of 0? Because on the right side it is like 1, 2, 3, right, like that, right? In the left side there is negative 1, negative 2, negative 3, like this. Okay, now negative 0.23 will be somewhere here, right? Negative 0.23, because this is the middle one. Negative 0.23 will be left of 0, and it says find the area left. Okay, I always suggest you guys to draw the graph and then say the area that you wanted to find. In that way, it will be easier for you guys. Otherwise, sometimes you messed up the area. Do we need to find the left or right? The question says find the area left of G equals negative 23. So you need to find out this area. Okay, now how do I find out the area left of negative 23? So this value is negative 0.23, right? Again, what you do is go to the calculator. All right, so let me clear everything here. Go to the calculator and do second verse and then pick the normal CDF. Okay, normal CDF, and hit enter. And then what is the lower bound here? Lower bound means the left bound. There is no bound on the left, right? Because all the area left of negative 0.23 goes through all the way somewhere here, right? And then you pick a small number for the left bound. Right bound is negative 2.23. The right side boundary is negative 2.23, but the left side boundary you can take very small number. I'm taking negative 10 to the 99. That will be small enough, right? What is the upper bound here? So upper bound here is negative 0.23, negative 0.23. That is the upper bound. And what is the mean? Mean is 0, sigma is 1, because it is the G distribution. We are finding the area under G distribution, right? So you paste it and then hit enter. This is what you get. So this is the syntax you use in TI-83. You do normal, you get normal CDF by second verse and the normal CDF. Pick the left bound, any number on the left. You can pick negative 10 to the 10 or negative 1000 or negative 100. That's fine, because if you go all the way negative 100, then it picks most of the area to the left side, right? And then the right bound is negative 0.23, and then 0 and 1 is the just default. It is 0 and 1 are the mean and standard deviation. And if you hit enter, it will give you 0.4090. Okay, 0.4090. What does that mean? That means this area is 0.4090. That means how much? 40.90%, right? And that makes sense because this shaded area is less than 50%, because it is starting from left of 0, right? All the area left of 0 is 50%, but all the area left of negative 0.23 will be 40.90%. So what is the calculator syntax for TI-83 calculator? Is normal CDF, right? And then negative 10 to the 10. You can do negative 10 to the 10 or 99. That's fine. Negative 0.23. That is left bound, right bound of that shaded region, and then 0 and then 1 are the default values for the G distribution. Okay. If the mean and standard deviation are different from 0 and 1, the question will tell you, and you will enter those values there. Okay, that's what you get. All right, so that is for the area to the left. Now, how do you find out the area to the right? That is another type of question. Okay, so I will discuss that in the next video, guys.